Let us move to the force exerted on a stationary curved plate. See, this is your curved plate and it is fixed stationary. So here the two conditions we will discuss here. See, one is the jet striking at the middle of the curve and the jet striking at the tip of the curve or the tip of the curved plate. So here let us discuss first the jet striking at the center of the curved plate. Okay, let us see first what we have. He has given. Uh, Let a jet of water strikes a fixed curve plate at the center of the as shown in the figure. The jet after striking the plate comes out with the same velocity if the plate is smooth and there is no loss of energy due to the impact of jet, that we have already discussed. All the cases we are going to deal with the in the same way. The assumptions will be same. The plate is smooth and there are no impact losses. If they are not there are no impact loss and the plate is smooth, then the velocity at which it's striking, with that velocity it will start moving along the plate and it will release or what you say escape from the plate. Now in the tangential direction of the curved plate, it will be the water or the jet will be escaping in the tangential direction of the curved plate. The velocity at the outlet of the plate can be resolved into two components, one in the direction of the jet and one is perpendicular to the direction of the jet. See, here the curve here leaving at which is in a tangential direction can be resolved into x direction and y direction. Sorry, x direction and y direction. X direction is nothing but opposite to the jet. So this is moving in this direction. This will be the opposite to the jet. That what he has said. One is in the direction of the jet and the other is the perpendicular to the direction of the jet. This is the perpendicular to, this is the direction of the jet and this will be your perpendicular to the direction of the jet, that is v sine theta. Next, the component of the velocity in the direction of the jet is minus v cos theta. Here the negative sign represents the opposite to the jet. Okay, the not numerically you are going to represent it, but the negative sign only represent that the it is in the opposite direction to the jet. Okay, that what he have given. Negative sign is taken in the velocity at the outlet in the opposite direction of the jet of water coming out from the nozzle. Next, component of velocity perpendicular to the jet. Perpendicular to the jet, it will be v sin theta after resolving by the help of triangle which we have already discussed. Next, force exerted by the jet in the direction of the jet. So force exerted in the direction of the jet, that will be your rate of mass, rate of momentum. Rate of momentum we have already discussed. So it will by taking the mass and the time common, it will become mass per second into v initial in the x direction minus v final in the x direction. V initial in the x direction is he has represented with v 1x. V final in the x direction he has represented in v 2x. So v 1x is initial velocity in the direction of the jet, that is v here in the let's observe in the figure that vx1 is in the direction of the jet initial velocity v, and next the final velocity after striking the x direction, the velocity will become v cos theta, that is minus v cos theta because it is in the opposite direction. So by substituting the v1x and v2x in the whatever the values we have got in the above relation, you will get that f of x is rho a v minus of minus v cos theta, that the whole thing will become rho a v plus v cos theta, and rho a you take v as common outside, so rho a v square 1 plus cos theta. You will be left with rho a v square 1 plus cos theta. So in the similar way, if you do for the forces in the y direction, initially there is no y component here. While the jet is leaving from the nozzle, there are no y components, only moving in the direction of x. Later there is a y component when it is after striking or when it is leaving from the vane, that is v sin theta. The same you will represent here. v1y means it is the initial velocity before striking. v2y means it is the final or the later velocity after striking. Now if you are substituting v1y, it is 0, and v2y, that is v sin theta. So here you will represent both the things, and you will come to know fy is rho a v, initial velocity is 0, final velocity is minus v sin theta, that is minus rho a v square sin theta. You are left with this is the force exerted by the jet on a curved stationary plate. And now there is another case where jet strikes the curved plate. We will discuss in the next video.